Okay, since valence electrons are responsible for atoms interacting with each other, and so for the formation of compounds and for the chemical reactions that take place in the world, we need a way to model them, a way to model where those valence electrons are and how many there are. And we do that using these Lewis dot symbols. So let's go back to our trusty example of carbon 12, which we said had an electron configuration of 1s2, 2s2, 2p2, which in our valence shell of energy level 2 then, there are 4 valence electrons. So a Lewis dot symbol then would represent each electron as a dot, each valence electron, and we try and distribute them evenly around our chemical symbol. So 4 valence electrons, 1, 2, 3, 4. So each one of these dots represents the 2 electrons in the 2 s orbitals, and 2 of these dots represent the 2 electrons in the 2p subshell. Sorry, I use orbital and subshell. They mean the same thing. So let's do another example. Let's take oxygen. Oxygen has an electron configuration of 1s2, 2s2, 2p4. So that's a total of 6 valence electrons. So let's put our chemical symbol for oxygen. Let me switch colors to show the electrons. So again, we just distribute them evenly. So we could go 1, 2, 3, 4, 5, 6. But that's not the only way you could do it. So I'm going to put a whole bunch of oxygens here and show you all the different ways you could write these. You could have gone 1, 2, 3, 4, 5, 6. Or you could have gone 1, 2, 3, 4, 5, 6. Or maybe 1, 2, 3, 4, 5, 6. So it doesn't matter which version you use, it's just a model. And the model represents the valence electrons in their subshells. Now, some models are better than others. So, for example, the way we have this drawn, we have 2 sets of electrons that are paired and individual electrons that could go on perhaps to form bonds later, and we'll talk about that. But right now, any of these Lewis dot symbols are correct. It's just a way to model on paper where the valence electrons and how many there are. So in this case, we have 6 that we want to show on our picture. So let's do another example. Let's do O, oxygen with a charge of -2. So it gained 2 electrons in the valence shell to have a net negative charge of -2. So that means we had 6 electrons before, we have 2 new ones. That's a total of 8 valence electrons. So if I want to show that on my oxygen atom, for this ion, I would draw 1, 2, 3, 4, 5, 6, 7, 8, and then I would come back and make that one darker so you can see it. Maybe I should make them all darker. It's kind of hard to do this with a stylus. And then I would put brackets around it and show the charge. So when you draw the Lewis dot structure for an ion, you need to show what the charge is. And you use brackets to do that. And then here's again our electron configuration for this particular ion. So let's do one more example. Let's do calcium ion. So the calcium ion has a charge of +2. The chemical symbol for calcium, if you look it up, is calcium with an atomic number of 20 and a mass number of 40. So that means if we have 20 protons in neutral calcium, we have 20 electrons. And now if we're talking about our ion form of calcium, if it has a charge of +2, we've lost 2 electrons, which means now we only have 18 electrons left in our calcium ion. But we want to make sure on our Lewis dot symbol, we're only showing the valence electrons. So if I wrote my electron configuration out for calcium, it would look like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. But I know now for my ion that in order to lose 2 electrons and form my +2 ion over here, so that I only have 18 electrons left, that the 2 electrons I'm going to lose are these 2 in the valence shell. So that means that if I write my Lewis dot symbol for calcium, showing its 2 valence electrons, 1, 2, when I write the Lewis dot symbol for calcium +2 ion, and those 2 4s electrons are gone, then there is nothing to show in terms of electrons around that calcium. So the Lewis dot symbol for the calcium ion looks like this because we've already ripped off those 2 valence shells. Now it is true we have a new valence level, right? It would be level 3 where they have the complete S and P subshells have been filled to 8 electrons total. But that's at the end. So there's no more chemistry that can happen now. So at this point, we're showing that the outermost energy level, which was energy level 4, is now empty. So sometimes it might be useful to write the electron configuration for the ion showing that empty energy level. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s0. So that's showing for this calcium ion that we've taken out those last electrons and now have our new Lewis dot symbol for calcium +2.